In Algebra 2, when we were studying all of our different types of functions, one of the types of functions we ran across was radical functions. Well, when we were solving radical equations, you got to be careful of the type of radical you have, whether it's a square root, cube root, fourth root. So we're going to start with something simple. How do I solve this equation for t? Well, since it's a square root, to get rid of the square root, you square both sides. And the square and the square root, in essence, cancel each other because they're inverse operations. And then you just finish the problem off by subtracting 1 and dividing by -3. And don't forget to double check your answer and make sure that it works. Before we get rid of a radical, though, we have to make sure the radical is isolated. So if there are any numbers that are not underneath the radical, they have to go away using your normal inverse operations. So first you would subtract 12. You get -9. And now you can get rid of the cube root by cubing both sides. So I would get x plus 4 is equal to -729, and then I would subtract 4 and I'd get -733. And don't forget to double check your answer. And one of the things we talked about in Algebra 1, Algebra 2, was that when you square root something, the number that's going to come out is going to be positive. So in this problem, when I isolate my radical first, I end up getting the square root of x minus 4 is equal to -3. Now I realize you want to look at it and go, oh, okay, well, I'm just going to square both sides, and I'm going to get x minus 4 is equal to 9, so x is equal to 13. And then you go and you plug it back into the original equation. 13 minus 4 is 9. Square root of 9 is 3. And 5 plus 3 is not equal to 2. Well, if 13 didn't work, then this must be no solution. And the reason that it's no solution is because when we come back up here to this step, the square root of x minus 4 equals -3. The square root of x minus 4 cannot equal a negative. As a matter of fact, no even roots can result in a negative. Only odd roots. So if I come back here, the reason that the cube root of x plus 4 equals -9 is okay is because when you take a cube root, you can get a negative. But when you take a square root, you cannot. Sometimes we had problems that had radicals on both sides. That's okay. In this particular problem, since there are no numbers outside the radical, I can get rid of these square roots just by squaring both sides. Now, again, don't forget to check what kind of a root you have. The number one reason that students get these problems wrong is they always try to square every type of radical, even cube and fourth roots, so be very careful. All right, so I squared both sides, and I'm going to get my x's on the same side, and then I'm going to get my constants on the same side, and I'm going to find out that x is 14 over 4, which reduces to 7 over 2, or you can say it's 3.5, but either way, if you double check it in the original problem, it works. The problems got more complicated algebraically. The inclination of most students is to do this. And that's not how solving radical equations works. You can't just square every item. Instead, what we would have to do is square each side. And that's where the algebra starts to get kind of tricky. I'll tell you that a problem like this, it works a little bit nicer if you move one of the radicals to the other side. So I took the square root of a minus 3 and subtracted it from the other side. Now I'm going to square both sides. On the left-hand side, that's square and square root. They cancel each other. But on the right-hand side, I am going to have to write this twice, because remember, that's what squaring says. And then I'm going to have to distribute those binomials. So I'm going to get 49 minus 7, the square root of a minus 3, minus 7, the square root of a minus 3, plus those two square roots, when I multiply them together, it's like squaring, because the square root of a minus 3 times the square root of a minus 3 is the square root of a minus 3 squared. That means the square and the square root are going to cancel each other and be left with a minus 3. Now I'm going to have to isolate the radical, but we're going to have to do some combining of like terms here. So I can combine these. So I can get 46, I plus a, and then these combine to minus 14, the square root of a minus 3. Remember that adding and subtracting radicals works like adding and subtracting like terms. I'm going to subtract the 46, so I'm going to get negative 42. I'm going to subtract the a's, and they're going to cancel. Now I'm going to divide by negative 14, because I'm still trying to isolate the radical. So I get 3 is equal to the square root of a minus 3. Now I'm ready to square them again. 9 is equal to a minus 3, so a is 12. Now that was a lot of algebra, but I wanted to go back and review the algebra before I go and talk about how to do it on the calculator. In order to have the calculator help you out, we're going to do the same thing we did with rational equations. We're going to first rewrite this equation so that it equals 0. And the fastest way to do that is to subtract 2. And then we're going to go put into y1 equals the square root of 1 minus 4t minus 2. And don't forget, in y2 equals, we want it equal to 0, because what we're going to do is we're going to find the point of intersection of our graph with the x-axis. So here's the graph, and you can see it's hit somewhere in the negative x-axis. So now when you do second trace 5, enter, 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 it should tell you at the bottom of the screen, that it was negative 0.75, which is the same as negative 3/4, which is the answer we got when we did it algebraically. In this example, we had found out that the answer was negative 733. So if you were to go put this into your calculator, and you would put it in as y1 equals the cube root of x plus 4 plus 9. And remember, the cube root is under the math function. You wouldn't be able to see it on the screen. You would probably be able to tell by looking at the graph that it was somewhere in the negative region, and you could play with the window. This might be a problem where it was much nicer to use Desmos and zoom out. In this example, in order to set it equal to 0, I would subtract 2. So then I would put y1 is equal to 3 plus the square root of x minus 4. Now when you put it into your calculator, you would see that the graph over here is going up and away from somewhere. So it doesn't look like it's going down towards the x-axis. Well, if it doesn't look like it's going down towards the x-axis, then it's probably never going to hit the x-axis, which is why it's no solution. In this example, in order to plug it into the calculator, I would have subtracted square root of 2x plus 10. And then when we put into y1 equals, we would get this graph, and clearly it hits the x-axis, and you would do second trace 5, enter, 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 and it would tell you that it hits at 3.5. This last example was actually a good one for using the graphing calculator to help us, because the algebra involved in finding the final answer was a little daunting. So what I would do in order to set the equation equal to 0 is to subtract the 7. That's the fastest way. Plug this equation into y1 equals, and then graph it. Now, on the standard, I actually redid the window, because on the standard viewing window, we know the answer is 12. It doesn't hit you don't see it hit the x-axis. But you know it's going to hit the x-axis somewhere past 10, because you can kind of see what it's doing. So if you know that it looks like it's going to hit the x-axis, then just go to the window function and change the window so you can see where it hits before you go and use second trace 5, enter. Again, on Desmos, it's a little bit easier to maneuver the screen to find what you're looking for, but you can't use Desmos on a test, so we still want to learn how to do it on the graphing calculator. And that was solving radical equations. We didn't focus on the inequalities, just the equations. If you would like to learn the radical inequalities, you can ask me outside of class.